Okay, now there's a lot of, this is all about salt here, so I'll have to just give you a quick explanation because you need to understand about the salt problem as far as regards to coal seam gas as well. But remember, salt is just a substance that dissolves in water. So wherever these water currents, remember originally the edge of the floodplain was the low point, so the water currents all used to move to the edge of the floodplain on both directions. Those floodplains are what we call salt processing plants. Salts are just excessive plant nutrients. So if you've got these salts entering the edge of the floodplain, you've got a massive growth of wetland plants. They take up all this excess nutrient. Of course, the animals, the insects eat the plants, the birds eat the insects, and those excess nutrients are then spread through the food chain. That's how the system naturally cleans itself. But over time, the river channel itself becomes the deepest channel in the floodplain. Now all currents flow to the new low point, which is the river. Of course, bringing all the salts with it. So where before the wetland used to process the salts, now the salts simply accumulate in the river and the river bank. And if you have a look at any statistics of the rivers in Australia, you'll see that they're all turning salty, and in particular the Murray-Darling. I mean, the Darling's quite salty, but when you get to the end of it, down at the end of the Murray, which is down near Adelaide, the water is so salty you can't drink it anymore. And that has massive ramifications for their drinking water, because they used to take most of their drinking water from the river. But this is happening all over the country. All our rivers are turning salty. And this is the process that's caused it. But not only that, a lot of the excess salts now sink to the bottom. Before, salts are naturally produced through the decomposition of organic matter through the breakdown of rocks and soil. But in this process, we're now adding huge amounts of salts in the form of fertiliser. So where before the natural system could cope with the small amounts of salts that are released, when we started pumping chemical fertilisers out of control onto the farms, of course plants can only take up so much. The rest all ends up either leaching down into the bottom of our floodplain or leaching into our rivers. Now if it's not too salty, it'll create an algal bloom, that's just excessive nutrient. But if the salt concentration gets so strong, even the algae won't grow, even the salt water becomes so polluted that it actually starts to crystallise out and crystallise salt particles. When the water evaporates, you get these salt particles forming on the surface, and you can see that in a lot of the places in Australia now. The farms have got a white colour to them, and that's the salt crystallising. Now keep in mind, the farmers have created this in part their own self by over-fertilising. As soon as we began to use chemical fertilisers, we began to salt the landscape basically. Okay, so now we've got salty rivers. Because they're, what the farmer does is he then irrigates out of those salty rivers, and then the water evaporates from the sun, and that's how we believe the salt sitting on the surface. Now that's a very different process to if you understand what the scientists believe about the water tables rising and bringing the salt up. So it's a bit of a, for anyone here who's a scientist, it's a bit of an opposite perspective to what you might think. But just let me carry on. I don't have time to explain that perspective as well. But you'll get to see we've done this process so many times that if this wasn't right, then we would be destroying floodplains, not rebuilding them. Okay, so can we go to the next one? But basically from that, yeah, okay. Then eventually, the centre channel becomes so deep that the groundwater can actually drop below the river channel itself. That now appears that we have dry rivers, but in fact the river is still in that channel below the ground. At that phase there, we pretty much turned what was arable land or fertile land into a salt desert. And that's pretty much what's happened all over this country. Probably half of the deserts we have in Australia are not natural deserts, they're man-made salt deserts. And it's all due to clearing the land and that erosion process beginning to take place, and then the over-fertilising or the overuse of chemical fertilisers. Okay, that's the process that we're at now. Do you want to go to the next one? This is how our rivers should look. This is taken from a natural river system. There's a floodplain with still mostly grasslands. Our hills still well vegetated, and that's how a river should look. Not sitting in a channel, sitting fairly level with the ground. The only reason it looks like it's in a channel is because of the length of the grass, but in fact the river itself is sitting at ground level. That's how all our rivers were, and I would be struggling to find you one of those rivers today. Anywhere in the country, for that matter. And even places where we think aren't that degraded, I still struggle to find places like that. Go to the next one. Okay, this is, I'm going to just go through it again, but looking from the top view down. So before we were looking at a cross section, now it's as if we're flying in an aeroplane and we're looking down onto the floodplain. Okay, this is what we call a choke point. So anywhere where the floodplain is narrow, we call it a choke point. Here the floodplain is nice and wide, and then we go back to another choke point. Now remember, this could be a long floodplain with many choke points. I've only just taken a section between two. What happens here is, when this is just to give you a better idea of how the landscape forms. Okay, at these choke points, okay, you get, when we get floods, remember that the actual floodplain is built by flood events. So when we get a flood, as the flood waters, that's when the river overflows and the whole valley is now flowing. When the water reaches this wide part of the valley, it flows quite quickly. But then when it starts to get to this choke point, water begins to back up on itself, and it ends up dropping sediment out of suspension and creating a sandbar or a step. This also creates one along this choke point as well. And in all natural floodplains, at every choke point, there is actually a step in the landscape. You won't find it in many places now because they've all been blown out. Because as soon as the plants were all lost, the soil dried out, all those banks basically blew out. But I can still find remnants of these steps everywhere in the landscape. Because behind the step forms a pond. So there's a natural pond. So this is how our rivers should look. Behind the pond you've got the rifle or the main flow line. And then after the pond it breaks over this step and causes a series of streams which we call a delta. So in a natural river system you would have a pond into a series of deltas, back into a main flow line, back into a pond, through a series of deltas and back into a main flow line, on and on at each choke point. There was no such thing as just a flowing channel. That didn't occur. Because you also had the secondary channels, and from the secondary channels did all the billabongs form. So any ponds in the main flow line are just called a pond. They're part of the main flow line. All the billabongs are part of the secondary flow lines. Okay? Here you can see the wetlands. The light colour represents the wetlands, and that last photo I showed you was looking at this part of the section of a wetland here. So there was predominantly grasses in this area. Then there's the low point of the floodplain. Remember the original picture showed you the low point in the floodplain was the edge of the floodplain. So that represents the wetlands running along the edge of the floodplain. The dark green is the trees running along the riparian zones, which are the edge of the rivers. And then you've got the wetlands surrounding the billabongs because they sit in the low points in the floodplain as well. Okay, so that's how we should be running, and that's how our rivers should look. Go to the next one. Okay, the first thing we did is we cleared the trees. Not only did we clear the trees on the hills, but we cleared the trees around the riparian zones as well. Often, years later, they replaced them with willows and things like that, but originally they cleared them. Okay, as soon as they cleared the trees, we basically straight away had a problem. Go to the next one. Okay, that's basically what happens. Remember we showed you the erosion occurring in that first cross section? Well, there's where the river is meant to be. That's where the farmer's standing. Okay, we cleared all the vegetation, they cleared the landscape, water now flows quickly off the hill into this, and it's created this eroded channel. So the river did once sit at the high point, and if you look closely you can actually see the landscape slopes back down from the river. So that was the high point. As soon as we cleared the vegetation, erosion took over, the river now runs through that deep channel, and that was after one flood. So when you look at some of the channels our rivers flow through, think of how deep and how wide they are. They could have had many floods over the last 100 years, so they build very quickly. Okay? So that's just an example of what you see the river where it's meant to sit and where they predominantly sit now, which is down here. Okay, next one. Okay, what you're looking at now is that process. That river is now eroded into a channel, and because it's eroded into a channel, the water table has dropped, and now the wetlands have dried up, the edge wetlands have dried up, and even the secondary flow lines are beginning to dry up. Next one. Okay, what happens now is you get blowouts. Once you have a channel forming, that channel under high flow can get blowouts. So we'll just for an example, we'll take a blowout here, and a blowout through that pond there. Okay, go to the next one, and you'll see it'll follow the old flow lines. So it blew out there, it just followed one of the old flow lines, and it comes back in again. It blew out here, it just follows the old flow line. That's where the edge of the floodplain begins to get deeper and deeper because I've now got water flowing through that channel along the edge of the floodplain. Okay, keep going. Okay, eventually the centre channel becomes the deepest. When we were looking at that cross section, when the centre channel becomes the deepest, these ponds, these banks have now blown out, so I don't have a pond forming anymore. I just have a stream, a deep channel running through there. Down, as you can see, each flood event, the river gets eroded wider. It originally went there, then it went wider, and now it gets wider again. So it starts to develop deep channels with these big step sides on them. Next one.